Let's continue with physics chapter 2, physical quantities and measurement, and we were learning about density. Today we are going to study about concept of flotation and sinking of a substance. Okay, so why do some substances float and why do some substances sink? In order to understand flotation and sinking in more detail, we must understand the concept of relative density. So let me give you a brief idea about relative density. Okay. What is density of water at 4 degrees Celsius? Do you remember? Density of water at 4 degrees Celsius, as we have seen in the table previously in the same chapter, is equal to 1000 kilogram per meter cube or 1 gram per centimeter cube. This is the density of water at 4 degrees Celsius. So you must be thinking, if we want to find about relative density, why are we studying the density of water? Why are we writing the density of water at all? Because relative density of any substance, let me write the whole thing, relative density of any substance, of any substance is equal to density of that substance, density of that substance, okay, upon density of water. That is the formula for relative density of any substance. And what does relative density tell you? Relative density will tell you whether a substance will sink in water or float in water. Okay, let me write that also. Relative density tells us whether a substance will sink or float in water. But how does uh, relative density tells us that? Let us understand with an example. Okay. Now, first, for finding relative density of any substance, you should always remember that the unit of the density of any substance, whether it is kg per meter cube or gram per centimeter cube, whether you take the unit of density of any substance as kg per meter cube or gram per centimeter cube, the density of water should also be the same, that is kg per meter cube or gram per centimeter cube. So if you take the density of a substance in kg per meter cube, the density of water has also to be taken in the unit of kg per meter cube. Always remember that. If you are taking the density of a substance in gram per centimeter cube, okay, if you are taking the density of any substance in gram per centimeter cube, then take the density of water also in gram per centimeter cube. So always remember the numerator and denominator will always have same unit of density, whether it is SI unit, that is kg per meter cube, or CGS unit. Okay, let's take an example. Let's find relative density of wood. Okay, relative density of wood. What is relative density of wood? Density of wood upon density of water. Now let's find what is the density of wood. From the table, we already have a table. Yes, so in this table, the density of wood is 0.68 gram per centimeter cube or 680 kg per meter cube. Any one you can take. Okay, uh, I will show both of them. Okay, 0.68 gram per centimeter cube or 680 kg per meter cube. Okay, let's first take in kg per meter cube. 680 kg per meter cube. That's the density of wood upon density of water. Now, density of water has also to be taken in kg per meter cube because we have taken density of wood in kg per meter cube. So, density of water is how much? 1000 kg per meter cube. Now, this 0 cuts with this 0. Kg per meter cube both gets cut, and 68 divided by 100 we get, which is 0.68. What is the unit of relative density? It has got no units. Okay, so one more thing you must remember here is that relative density has no units. It's a number. It is only a number. It has got no units. Okay, let me also show you how to find relative density when we take the density of wood in gram per centimeter cube. Does not make any difference. So relative density of wood is equal to density of wood. Let's now take it in gram per centimeter cube, 0.68 gram per centimeter cube. That's what we saw in the table upon density of water, but also in gram per centimeter cube, 1 gram per centimeter cube. Okay, so this cuts right away and we get again 0.68. So it does not matter whether you take the density of the substance whose relative density has to be found out, and density of water in kg per meter cube, that is SI unit, or gram per centimeter cube. But if you put them in the formula of relative density, you will find the same answer. The answer of relative density does not change. And one more important thing which we understood about relative density is that it has no units. It is only a number. So how does it tell you about whether a substance will sink or float? I will tell you. But after a couple of more examples, I will tell you whether a substance will sink or float in water. Let me take one more example for you. Let me take example of iron. Okay, iron. What is the relative density? What is the density of iron? 7.8 or 7,800. Okay, now we'll take only in a single unit so that we can find its relative density fast. Let's find it. Okay, so relative density of iron is equal to density of iron in kg per meter cube. Let's take 7,800 kg per meter cube upon density of water in kg per meter cube, 1000 kg per meter cube. Okay, this will cut, 0 0 will cut, one more 0 will cut, 78 upon 10. 10 is 7.8 only. Okay, only a number, nothing else. So relative density of iron is 7.8. Okay, now let's find the relative density of water itself. What is the density of water? 1000 kg per meter cube. Okay, upon density of water, 1000 kg per meter cube. Everything gets cut, and what you get? 1. Okay, now we have got relative density of wood, which is 0.68, relative density of iron, which is 7.8, and relative density of water, 1. Okay, so the relation of sinking and floating objects with their relative densities is given as over here. Okay, let me write it. An object will float in water if the relative density of object is smaller than 1. If relative density of object is smaller than 1, it will float. What is 1? 1 is the relative density of water. So if any object has a relative density less than that of water, it will float. And an object will sink in water if relative density of object is greater than 1. If relative density of object is greater than 1, what will happen? It will sink in water. Okay, so now we can understand what will happen with wood and iron. Okay, now here it is very easy to note that 0.68 is smaller than 1, right? Therefore, the relative density of wood is smaller than 1. Therefore, we can say that wood will float in water. We already know that by our observations, and now we have verified it with the mathematical support, right? And with the idea of relative density. Acha, here relative density of iron is greater than 1, and therefore we know that iron will sink in water. Iron will sink in water. So wood will float in water and iron will sink in water. Okay, so this we know, this is very evident, and the idea, the concept of behind relative density and sinking and floating object becomes crystal clear from here. Okay, so I hope all of you have understood what is relative density. Relative density is density of any substance upon density of water, both being in the same units, right? Then you find a number which is relative density, and relative density has no units. It is only a pure number, right? So this number, if greater than 1, object will sink in water. If number is smaller than 1, then object will float in water. That is the whole idea behind relative density and sinking and floating objects. Okay, so that's what they have written over here. Okay. Next, we are going to study about some topics which are, you can say, practical applications of relative density. Practical applications of relative density. The change in density of seawater with temperature due to mixing of fresh water from rivers has serious effects on shipping. When a ship loaded to maximum capacity and enters a seaport close to a river, it is likely to submerge more in it and may sink. Even the seawater at different locations has different densities depending upon the geographic locations, which can be serious threat to shipping. For safety considerations, all the ships have marking on their hull to show the level up to which they should be submerged in the particular sea or river. These markings are known as Plimsoll lines. So, sea water has maximum density because there is a lot of salt dissolved in it. The density of sea water is more than the density of river water or pure water or sweet water, because of the dissolved salts. And that's why the ships, they do not submerge more because the density of water is more. So it will not allow the ship to submerge more even if it is fully loaded. But these ships which are designed to sail in seawater, when they enter river water from seawater, they submerge more because the density of river water is less than seawater. So there is always a chance that they will sink if they are fully loaded. So Plimsoll lines. Plimsoll lines are marked around the hull of ships to indicate the level to which ships should be submerged in seawater at some particular location. If the ship is not loaded up to the recommended level, it is likely to sink or overturn in a rough sea. So I will show you what a Plimsoll line is. Let me Google search and find some pictures of Plimsoll lines. Okay, let's see uh, this picture. Okay, so I hope you can see this picture. Now, if you see a real ship, you will see markings like this on the hull of the ships. This is the hull of the ships. Okay. Now, this these markings, they show that up to what level will the ship be submerged in certain type of water, whether it is tropical freshwater load line, tropical freshwater load line, which is TF, that is the top marking over here. Okay, whether it is freshwater load line, which is just below the tropical freshwater, tropical zones load line, summer load line, winter North Atlantic load line. So in different regions of Earth, there are different levels up to which the ship will be submerged in water. You don't have to remember all this. This is just for your general knowledge and information. I'm sharing this with you. So, if a ship goes from one region to another region in water, it might enter from seawater to freshwater or freshwater to seawater or from one region of world to another region through waterway. But since all the waters of the world don't have same density, like Dead Sea, which is in Israel, Dead Sea has the maximum density because it has got maximum amount of salt dissolved in it. There are no live creatures, fish, aquatic plants, animals, nothing in Dead Sea. That's why it is known as Dead Sea. And you can actually float in Dead Sea. You can never sink because it has very high density. So if some ship has to enter Dead Sea, then you can imagine how will it float. It will actually, the level of that ship, the level of water when that ship enters Dead Sea would be somewhere over here. And then just imagine if the water is just over here, most of the part of the ship is above the level of water, and that may make it topple or overturn due to rough winds or rough sea. So that is in that case you need to load the ship more so that it can submerge more. So these kind of precautions has to be taken in order to keep the ship safe and floating above the surface of water when it enters from one region to another. And Plimsoll line helps us understand how much the ship is sinking or floating above the level of water. And the direct application of this Plimsoll line comes from the concept of relative density, right? So that's you can say practical application of relative density. Okay, one more important thing you should know: the whales can sink or rise in water at their will, and also the submarines. Okay, let's talk about whales first. Whales have a special organ called swim bladder. In order to decrease the density, they fill the bladder with air, and thus they come to the surface of water easily. But to dive into the sea, they empty the bladder, and this increases the density and they sink easily. So whales have this kind of natural mechanism in order to float on the surface of water or to sink deep inside the sea, which is the swim bladder. Submarines, on the other hand, which are man-made things, submarines, they have this ballast tanks. So ballast tanks are special tanks which are attached with the submarines. If a submarine want to rise and come to the surface of water, it fills the ballast tanks with airs. So it is connected with pump. All the water from that ballast tank is removed with the help of pump, and air is filled in it. And as you fill the air in it, its density decreases and it rises above the surface of the water. Now, if it wants to go inside again, it will fill the ballast tanks with water, so that doors of ballast tanks will open and the water will fill in, the density of the submarine will increase and it will go down. So this is one important thing you should know, how the density changes in whales and submarines, and these things allow them to rise up to the level of water and then again go inside whenever they want. Okay, one more important thing, which is the practical application of relative density, and to understand relative density in, you can say, to a greater extent, you should always ask this question or find the answer to this question: why does an iron needle sink in water but not an iron ship? Iron needle is compact. Its density is 7.6 gram per centimeter cube, greater than the density of water. The density of iron needle is more than 1 gram per centimeter cube, and therefore it sinks in water. However, the iron ship is constructed in such a way that it is mostly hollow from within. It is mostly hollow. Do an experiment. Take a steel bowl from your kitchen and put it in the bucket of water and see what happens. Although it is steel, but it will float on water. Why? Why does it float on water? Because it is hollow from within. The shape of that bowl, since it has more air in it, most of the iron bowl is filled with air. It allows it to float on water. The same is the case with iron ship. Iron ship is hollow from within, although it is made up of iron from outside, but from inside it is hollow. So the volume of iron ship becomes very large as compared to its mass, and hence its densities decreases and becomes less than 1 gram per centimeter cube, and the density of iron ship is less than 1, hence it floats on water. So this is the scientific reasons why iron ships float on water but not an iron needle. Then we have to compare the densities in three states of matter. Now, it is very easy to compare. Let me give you a pictorial idea about densities of substances in three states. Uh, why don't we go to the first part? Yes, this part. And here, if we understand the three states of matter, and I will draw one more box over here and draw the particles which are close enough but not tightly packed. Okay. Okay, so let us consider this is solid, this is a gas, and this is liquid. Can you tell me which one has the greatest density just by looking at the arrangement of particles? Yes, now you can easily say, since more mass is packed in a particular volume in any given solid, hence solid has maximum density. Density of solid is maximum. So this is a general information, okay? Not accurate, because wood is also solid, but it has less density. Okay, but generally solid has the greatest density. Then comes liquid, since liquid has particles close but not close enough like solid. So the mass per unit volume of liquid is less than solid. So after density of solid comes the density of liquids. Okay, after density of liquid, the least density is of gases because the particles are very far apart. So density of gases comes at the last. Okay, so greatest density is of solid, then of liquids, and then of gases. This is how we can compare the density of substances on the basis of the states of matter. Understand one more fact. The density of ice is less than that of water, which is an exceptional case. Ice is a solid, water is a liquid. Still, ice has less density than water. Also wood. The density of ice, water and steam are 0.917 gram per centimeter cube. This is the density of ice. 1 gram per centimeter cube. This is the density of water. And 0.00057, which is the density of steam, which is a gas. Understandable. Okay. So we understood the concept of density in different aspects in this particular chapter. Also their practical implications: land breeze, sea breeze, Plimsoll lines, whales, submarines. Then how to measure density, that also we studied. What is density? What is the SI unit of density? How to find density? What is the concept behind density? Everything we studied in this chapter. So if anyone asks you any questions regarding density now, I think you should have no issues answering it. Okay, now I will just discuss briefly some numerical problems which are shown over here, some solved examples, so that you understand that you know how to solve these numerical problems from your exercise. Today we are finishing this chapter, and after this I'll be doing math for your upcoming exams. So this chapter will be over, and the exercise will be given as final assignment, final homework for this chapter. Okay, so let's first discuss the numericals. So a piece of lead weighs 232 grams. What is 232 grams? It is the mass. Okay. When they say weighs or weight and mass, for now is to be considered as same. Afterwards, we'll understand what is the difference between mass and weight. But right now, they are the same. So mass of lead is 232 grams, and it has volume of 20 centimeter cube. Volume is 20 centimeter cube. So we have mass, we have volume. Find the density. So density is mass upon volume. See, mass is in grams, that is the CGS unit of mass. Volume is in centimeter cube, which is the CGS unit of volume. So 232 grams upon 20 centimeter cube, if you divide, you get 11.6. But what will be the unit of density of lead? Gram per centimeter cube. Since both mass and volumes were in CGS units, the density will also have the CGS unit. Very simple. Let's go to the next question. 5 liters of alcohol. Okay, 5 liters of alcohol. This is volume of alcohol. 5 liter. Okay, they have converted in centimeter cube. Always remember, I'll give you one relationship. 1 liter is equal to 1000 centimeter cube. Okay, which is also equal to 1000 ml, milliliter. So we can say that 1 milliliter is equal to 1 centimeter cube. Okay, next time if this relation is in front of you, like if some question has been asked and they are mentioning liter or milliliter, you should be able to convert it into centimeter cube easily. 5 liters of alcohol is a mass of 4 kg. So mass is 4 kg. See, they have quickly converted this mass into grams. Why? Because volume is also converted into centimeter cube. So we want to keep all the units in CGS system so that the density comes out to be in proper CGS or SI system. Okay, so we convert this mass 4 kg into grams. Next is density of alcohol. We have to find the density of alcohol. So density of alcohol, D, is equal to mass upon volume, mass per unit volume. What is the mass? 4000 grams. What is the volume? 5000 centimeter cube. So density of alcohol will be 4000 upon 5000, which is 0.8 gram per centimeter cube. Okay. Now they have also asked us to find the density of alcohol in kg per meter cube. Now you should understand, I have taught you this earlier, to convert from gram per centimeter cube to kg per meter cube. What you should do? You should multiply by 1000. So here I've got 0.8. I will multiply 0.8 by 1000 and I will get 800 kg per meter cube. Is that the answer? Yes, it is. Easy. Next, always in in these kind of numericals, you should first read the numericals and then first list what is given and what has to be found out. Then apply appropriate formula, check the units before applying the formula, and put the values, get the answer. Simple. Find the mass of 555 centimeter cube of iron. Okay, so we have got 555 centimeter cube of iron, that is volume of iron, in kg. Find the mass in kg. Okay, so mass has to be found in kg when the density of iron is 7.6 gram per centimeter cube. Okay, so density is in gram per centimeter cube, volume is in centimeter cube. First let's find the mass in grams. So mass is, see, density is mass upon volume, so mass is equal to density multiplied by volume. Okay, so density 7.6 gram per centimeter cube, volume 555 centimeter cube. This centimeter cube and this centimeter cube will cut. You get 4218 grams. To convert from gram to kilogram, what you will do? You will divide by 1000. Gram to kilogram, divide by 1000. Remember that. I hope you already know that. So 4218 divided by 1000 is 4.218 kilograms. Easy? Yes. Next question. Now this is about density bottle. So this is about measuring the density of a liquid. A density bottle weighs 20.25 grams when empty. A density bottle weighs 20.25 grams when empty. 40.75 grams when filled with a liquid. And 50.25 grams when filled with water. Okay, let's list before we read the answer. Density bottle weighs 20.25 gram. You remember what did we give, what symbol we gave to the mass of empty density bottle? M1. What is M1? 20.25 grams. Okay, 40.75 when filled with a liquid. Okay, so mass of liquid is M3 minus M1. M3 is the mass when filled with liquid. What is M3? 40.75 grams. That is mass of liquid plus density bottle. So what is the mass of liquid only? It is 40.75 minus 20.25, which is 20.50 grams. Okay, and 50.25 when filled with water, that is M2. M2 is 50.25. M2 is what? Mass of water plus density bottle. So what is mass of only water? M2 minus M1, which is 50.25 minus 20.25, which is 30 grams. Okay, so we found mass of liquid, we found the mass of water. Okay, now we know one important thing which I discussed with you earlier. 1 gram of water is equal to 1 centimeter cube of water. Always remember that density of water is 1 gram per centimeter cube. So 1 gram of water will always occupy a volume of 1 centimeter cube. Now we have how many grams of water? 30 grams. Therefore, volume of water is how much? 30 centimeter cube. And volume of water is nothing but the volume of density bottle or the volume of liquid, because the liquid and the water in the density bottle all will have the same volume, right? So therefore, what do we have to find? Volume of bottle. Volume of bottle is 30 centimeter cube. We found it already. And density of liquid. What will be density of liquid? Density of liquid will be equal to mass of liquid, upon volume of liquid, which is equal to volume of density bottle or volume of water. Okay, what is mass of liquid? See, we found over here M3 minus M1, 20.50 grams. What is mass of, what is volume of liquid? It is 30. Okay, so this will become 205 upon 300 gram per centimeter cube. Okay, let's simplify this. Uh, if we cut them by 5, we get 60 over here, and here 5 fours are 20 and 5 ones are 5. 41 by 60. And if we divide 41 by 60, we should get a number smaller than 1, which is basically the answer over here, 0.683 gram per centimeter cube, which is the density of liquid. Easy. So if you have your concepts clear regarding density bottle, these kind of numericals are not a big deal. Now, what is the homework? Homework is to solve the whole exercise, the fill in the blanks. Always remember, fill in the blanks, you have to write the whole sentence while doing the homework. Correct statement, true or false, match the following, take the most appropriate answer. You can just write the statement and the correct answer in while you are doing the homework. Match the following, I already told. Study questions. These are theoretical questions which you have to write in proper sentences using keywords, technical terms from the textbook. And from question number 13 onwards, there are some numericals. So you will have a good time solving these numericals. We just discussed them. After that, some keywords and highlights are given. These are some short notes for your reference. Then there is this theme assignment. So this is also you have to do. This is also to be done by you. Fill in the blanks, true or false. Tick three, tick the most appropriate answer. Okay, I don't know why they have given 3. Statements given below are incorrect. Write the correct statements. Okay, that's it. And then there are some question and answers up to this. So theme assignment as well as the whole exercise with study questions and everything has to be done as homework. So this is your homework. Now the topic is finished. We have completed the uh, chapter 2 of physics very quickly. So now you have to just finish this exercise and get your doubts cleared with me. I'm going to make next video on mathematics so we can finish the important chapter, first chapter of algebra. Since we have completed 4 chapters of mathematics till now, and 2 of them were huge, that is your profit and loss and your percentage. With doubt solving, I think most of the doubts are solved. If not, then definitely I'm going to solve further. But before that, I'm going to start with algebra so that your syllabus is taken care of for your school exams. All right, so I'll see you in the next video. Bye bye.